Hello, this is Nam Nguyen. I'm a product manager for Geophysics and Interpretation. In this presentation, I'm going to talk to you about the new feature enhancement available in the new release 10ep.4. So here the highlight of the release. First is the wavelet convolution, where you can apply the filter in the wavelet operator form to your seismic data. And the second very important workflow is automatic seismic balance, which allows you to maximize the automation to analyze and correct the mistie across a large number of 2D seismic data in shorter time. On the right hand side here shows you the UI of the wavelet convolution in the seismic attribute workspace. So it's basically is a direct migration of post-stack wavelet convolution. The input wavelet can be created within decision space well-type workflows, such as a dephasing operator for zero phase correcting of the seismic, or any third-party software can use that to convolve with the seismic. Focus on the most important workflow, automated seismic balance. Typical workflow is start from select seismic data to the calculation. In here, I'm going to show the demo from a quick screening process to optimize the parameter for the best result. Then we move to a space where at some of the challenging type point, the automation might not give you a very stable result. In this case, the solution is to integrate between automated calculation and the interactive correlation of the seismic display intersection, and then update the edit mistie, and then based on that new mistie values, calculate secondary correction. The last step will be create a new seismic by process or apply the corrections that you compute from the seismic balance to create a new data set that gives you a good correlation, good tie across the multiple line, across multiple 2D surveys. So with that, we're going to go to the live demo. This demo will give you an introduction about how to use seismic balance workflow. There's 3 different 2D surveys showing in different color: the green, the light blue, and the pink. All the sections show a typical composite seismic section through multiple lines across those 3 surveys. The first observation here is we got a good correlation between seismic within the same 2D surveys. However, the mistie is significant across the surveys. On the right hand side here, the seismic correlation that allow us to analyze and fix the mistie per line individually. However, in this case, our goal is to automatically analyze and resolve the mistie of all the 2D line all together. To do that, we're going to launch the seismic balance. So let's go to the first step of select data. You can select any list from the database. However, in this case, we'll select the section line that I already displayed. When select the seismic, it's important to take a look at the number of the line or the line count of how many 2D line that have the same seismic volume. These have the most number of line. I'm going to select that. Furthermore, you can select more than one volumes. Second one. And now it had been selected and replaced in those 3 line. If you go to a combo box here, you will see now you can choose between either 2. I can highlight the multiple line and then do the MV3, set seismic, or click on the toolbar icon here and select the seismic. In this case, I will just simplify it. Select the mic.2v2. So with that, I have all the data I need. So the second step is to do a very quick screening or quick look analysis to just understand how are the mistie with all the lines together. So hit calculate. Immediately in the text area in the bottom of the UI, it will show you a summary of the calculation. Let's take a look into detail of how seismic balance calculate corrections. To do that, we're going to open the view report, the icon right here. Computation of correction is actually two-step process. The first step is to build a table of the observed misdive, which show in the lower table here at every intersection of every line. Right? And then based on that observed misdive table, it calculates the optimum corrections by applying the least square algorithms. That's showing on the top table here. So in this case, I'm gonna go in here and then turn off the input shift phase and gain, which is not applied yet. So here is the overall result, and I can go in and take a look into a very detail of each of them. A quick way to analyze the result is to just sort by a maximum correlation. Three lines here are the ones that have very good type. And then the second set of good set of line is the right one here. And then the last one is GMT. So if we're looking at the map, the good one is the green surface. The next good quality is light blue, and the lowest correlation that we derive from the quick screening process is the pink color survey. Now we can take a look not only on the maximum correlation, but also the minimum correlation. This will help us to identify where is the bad tie. This intersection have very low correlation. It go down to about 0.3. And then we can go to the other line here. And similarly, there is a bad tie point here. That is go down to 0.3. Let's experiment how it look if we use all of those tie points. So the default parameter here of the minimum score is a 50. So now let's switch it to 30 and see what the impact. So immediately you can see now is I have much larger shift at number of the line here. Save corrections, and so here I have two cases. One is minimum score equal to 30 and another one is 50. So let's take a look. So when we save the correction, it will automatically save a point set of the misdive, observed misdive in the open work. The recommendation of display the point set is to color code it by correlation and also control the size by correlation. One thing very useful in here is you just switch between observed correlation, which is best possible you can get, and compare it with actual correlation after apply correction. So the observed, and here is the least square optimization. The issue here, we have a very low correlation or bad tie. So now let's take a look into the scenario where we exclude the bad tie point. Now it shows a much better quality overall, and then there is few points of the low correlation down here. We're gonna look into detail of what are they. So in the map, I'm gonna select this intersection and go right here. And what we're seeing here is this is very end of the line where we don't have enough trace. That's why the correlation very low. So this is one typical bad tie point due to lack of data. Very near to the end of two line where we don't have data to do a proper corrections. So we can very easily identify the bad tie point. After that, can adjust minimum score to exclude the bad tie point. Right? And the default parameter of seismic balance had been defined as about 50, which allows you to exclude most of the unreliable tie point. Let's discuss how to identify and utilize the reference line to improve the confidence and the quality of the misdiag analysis. Open input data again, and now let's focus on the maximum correlation after the calculation, right? So obviously here we have the most reliable correlation for these three lines. Select these three as the reference. So what it does is it keeps the three lines that we select at the reference line unchanged, and then start adjusting the other line onto it. So now let's see, compare the impact of with reference and without reference. So now I'm going to change the method to free float. Calculate. So now note here that I have correction applied to those three lines, and also on the other surveys SD770 I have from 12 to like 6 milliseconds. Now after I apply the reference, so now on the line we adjust three reference line. So here I have a fairly good correlation at these surveys, and then I actually increase the internal correlation within the light blue surveys. That is very good, isn't it? Let's compare difference between observed with the correlation after the optimization. As you see here, they are very close. So using the right reference surveys will help to improve the confidence and quality of the misdiag analysis. Next step, we discuss a very unique way in seismic balance to analyze the misdiag among 2D survey very effectively. A 2D surveys or 2D vintage is a group of 2D lines that have been acquired and processed using the same parameter in the same time. Therefore, the good correlation within those 2D lines is expected. Let's go and investigate that. Just keep the only SD77 on the list and then do calculation. The report show that we have a very small difference between those 2D lines. 1 or 2 milliseconds, which is half of the samples. Also, the phase is very consistent. So this data set, these surveys are considerably good data. Here again, it shows a very insignificant shift between the lines. So the situation we have here is two different surveys, and within each of those 2D surveys, we have very good correlation. So the strategy in this case is to try to find a single correction set to all the lines belong to the same surveys, so that we only improve the misdiag situation across the surveys, but we don't generate any secondary misdiag side effect within the survey itself. So how to do that? We introduce the option of 2D surveys, toggle it on to activate it. To reset data very quickly, I just select correction itself. Now, all the lines belong to the same survey had been calculated and apply a consistent shift, phase, and gain together. Apply and turn on the reference. Okay, now other surveys had been applied a consistent correction to tie to the reference surveys. Okay, that is great. I had saved the result. So notice along the line right here, what the application there is it only calculate the intersection from one survey onto the other and use that to do the optimum corrections. So using this option, we gain two different benefits. Number one, minimize the number of intersection type points you calculate. so it have the performance, it have the optimization. And two is we derive a single consistent correction per surface, so that a final correction only have to improve the misstyle across the surface but keep the original good correlation within the surface. So now let's take a look how to quickly validate result of automatic correction optimization from seismic balance. Come back to this section where we display multiple seismic line across the three surveys currently working on. So we're gonna start from the left. This is line GMT 209, which is right here. Firstly, switch the seismic correlation parameter to be the same as in seismic balance. First off, we can see that correlation is slightly different. So let's do the autocorrect and see what happened. So maximum correlation is about 64. So let's reset it. And then now enter value that seismic balance suggesting. Okay, it's 61 compared to 65. It's very good. So now we're gonna go to the next slide right here. The interactive correlation tells us that it needs 28 shift and 32 phase rotation. The calculation from seismic balance is 28 milliseconds, so the time shift are matching, but the phase is a bit different. And keep in mind is the main difference in here, we have to take into account many other intersections, not only the one that display here. Do the auto correction, and we have the maximum about 59. Let's reset that, and then plug in the number that suggested by. All right, it looks pretty good. So when you compare between the automated calculation and the detailed QC and validate from the interactive, you can make a decision whether you want to change the observed mistake calculation here to give any particular type point have more controls, right? So one thing I can do here is I can go right here, change this, increase the correlation higher. Then similarly, I go to this line, that. Then now hit recompute. So notice the value in here. As higher value had been applied to the correlation, you see now it have a more influence in terms of time shift. Right? So you can continue keep doing that. Go in and edit the particular type point that you want to have more influence, and come back and do QC in the section to compare the results. Right? All right. We're going to discuss about how to review and compare different correction sets that have been created and process it in order to create new data set that produce a good correlation among all of the line. Once you open correction set, all the parameters associated with it will be restored, as well as the input data have been used. So I'm gonna go in here using the combo box, switch between different correction set, and then review the parameter and results. Launch mistake correction utility right from the icon on the UI. Correction that active in the seismic balance will be automatically loaded. We use the same seismic for all of the line, so you can also turn off this option and select the data set in this way. However, the recommendation is to always using this option, so everything consistent, the data input exactly will be US defined in correction set. And you can choose here to turn off or leave out any corrections or any combination of them. The recommendation is the looking at quick statistic and then make decision whether you want to leave out any of them. We have three line used as a reference. Then there is no correction applied to it. However, you can make a choice to whether you want to output the line as a new seismic, so that the new set of seismic will have the data in every single line, and all of them will tie together. Specify the output seismic, and then launch. Before and after, before and after. So notice all of the line now have a very reasonable correlation. We have a good correlation of 63 consistently throughout every intersection across the different surveys. In addition to the automatic seismic balance workflow that you saw earlier, here are the additional enhancements were requested by customer in 10ep.4. First is volume visualization. You are now able to do probe intersection display for horizons and phone in the cube views. There's a number of improvements on well-timed synthetic workflow, including an option to select sonic or density curve to compute the impedance. And secondly is the ability to query and set the associated time depth curve of the active synthetic loaded BSG section. Probe intersection had been implemented for horizon and phone in cube views. The control of the intersection is enabled in the display property dialog. For horizon, you can find it inside display type sections. You have full control of color as well as the thickness of the intersection, particularly for phones. To support the phone slicing workflow, you will have an option to display the origin and the ship location simultaneously for the validation. With that, let's take a look into a live demo of the probe intersection feature. In EP4, we introduced a new functionality of intersection display where you can show exactly the line that intersect of horizons onto the probe, and it will apply to any probe that display in the cube. Furthermore, you can easily control whether you want to see the intersection only, which allows you to have the same experience as you working in the sections. Everything look very sharp and clear. Looking at the lower reservoir zones, and here we have a number of phones. Similarly, for phones, open the display property. You have a full control of display intersection with color and thickness as well. Now we can see all the horizon and phone intersection on the probe very clearly. On a particular one phone, if you apply the phone slicing, you can see not only the slicing phone plane, but also the original location for validation. With that, is conclude my demo of probe intersection. Thank you. Here's the first improvement in well-timed synthetic workflow. From MB3 menus on the RC and impedance track display, you can access parameter dialog. In there, you will find three new options. The first one is the default, that it will use the sonic and density that you selected from the wizard to compute the impedance, or you can quickly select the sonic only. In this case, it will set the density equal 1 at the constant values. So note that now the min max of the acoustic impedance be similar to the sonic or velocity input. You can also set it to the density. In this case, similarly, sonic will be assigned a constant value of 1. Acoustic impedance will have the similar range as the Roby. The second improvement in this workflow is the ability to quickly query and set the time depth curve that associated with the active synthetic loaded into the DSG section. First is through the MV3 of the synthetic loaded from the inventory. You will find the new option of load time depth curve of the active synthetic. You can select single synthetic or multiple of them, or the own synthetic entry. It will find the well that does not have matching synthetic and time depth curve and correct that for you. The second is using well details. Just highlight the wells that you want to query for. Click the icon It will run through all of the selected well and find out which well that does not have match between synthetic and the time depth curve, and pop up a confirmation dialog for you. This concludes my presentation of new feature in geophysical interpretation in the new release 10ep.4. Thank you.